Let's assume that we have the continuous time Fourier transform of a function or a signal and x of omega. So in this example, we have x of omega is equal 5 plus j omega divided by 2 plus j omega multiplied by 3 plus j omega. So how can we find the inverse? It means how can you find the signal expressed in time domain? Well, when you look at this expression for x of omega, you'll find you have constant plus j omega, but it's kind of complex a little bit. So if you go to the Fourier transform, you know that the one that will give you 1 over real number plus j omega, it's e power minus bt ut. If we just can go to the Fourier transform pair, the table given to you, you'll find that's the one that has real plus imaginary as a rational expression. So, but this one, this example here given, maybe it looks a little bit complex. Well, so how we'll do that? There are certain steps you follow, it will be easy. First of all, just to make it look nicer, just call S j omega. So replace every j omega by s and write the expression of s. X of s is equal to s plus 5. Yes, I know it's 5 plus s, but just I'd like to write s in the beginning. And 2 plus j omega, 2 plus s, I'll write it s plus 2 times 3 plus j omega will be 3 plus s, or you can write it s plus 3. So that's the expression you have, and we need to find x of t. So what is the strategy to solve this? You will like to break it into fractions and expressed in this way, in simple way. We'll do that by writing this expression as you have s plus 2, one denominator here, and another one s plus 3, but we don't know what's in the top. So we'll say it's a constant a, and here is a constant b. And simply what you're trying to say, you say that this expression, this rational expression, I want to break it into two. One has denominator s plus 2, but we don't know what is the numerator here. And the other has denominator s plus 3, sorry. That's s plus 3, and you don't know the top part b. So a and b are unknown, and we wish if we simplify this expression, we can get back to this. Then you might ask yourself, so why you are breaking into two? Because if you are going to replace in the end s by j omega, you have something divided by j omega plus 2, it in the same form. So you can find its inverse by using the table. That's why we are doing that. So let's go ahead and start doing it. So that's s plus 2. You want to have a common denominator. So you multiply it by s plus 3, and at the top s plus 3. So no change happen here. And this is the constant a. No change. Plus this term is b divided by s plus 3. Then you want to have a common denominator. You multiply s plus 2, and then the top s plus 2, no change. So by doing that, you have a common denominator. It's just one denominator, so you can write the whole thing over one denominator, which is equal to s plus 2 times s plus 3. In the top here, a times s is equal as plus a times 3 is equal 3a plus the second term, b times s is equal bs plus b times 2, it's equal to 2b. Now you collect like terms, so you have as here and you have bs, so you take s as a common factor, and what you have here, a plus b. So we are done with this one. Left 3a plus 2b, they are a constant term, 3a plus 2b, and the whole is on s plus 2 times s plus 3. And the whole thing now should be equal to the original expression. So just I'll put it there. S plus 2 times s plus 3. And at the top you have s plus 5. So the denominator, they are equal, so the numerator should be also equal. So compare that. You have s here, the coefficient of s is equal 1, right? The coefficient of s is equal a plus b. So you can say equate them to a plus b. Or let me just write it, you know what I'm doing. The top part here equal the top part here. So you can write s plus 5 equal to s plus b times s plus 3a plus 2b. So the top part equal to top part. So this term is equal this term. So here we have 1. So you have 1 is equal a plus b. That's the first equation you have. The second one, that's 5 equal this constant term. So 5 is equal to 3a plus 2b. So you have two equations of two unknown. A and b are unknown. Just do it in the calculator using solving linear equation of two unknown. Then you will find the value of a and b. In this case, we'll find the value of a is equal 3 and b is equal to -2. So you got the two unknown value. So what you will do with these two values, you put it back here. It's the same because that's x of s. It's equal this or that. I prefer to express as a sum of two terms so we can get the inverse. So write x of s now is equal a over s. Let me just remember a over s plus 2. This is the first one. So a, that's equal 3s plus 2 plus b, which is -2 over s plus 3. Now we can go back and replace s by j omega. So yes, so we write this omega, that's the Fourier transform, and 3 over s j omega plus 2. But I'd like to write it in a way that you can see it in the table, 2 plus j omega, and you have here minus 2 in the top of j omega plus 3. I'll write 3 plus j omega. So that's the expression of the Fourier transform, but I want to find the inverse. Let me remind you. So now it's easy. Each term has inverse. Why? Because of that. E minus bt ut is equal 1 over b j omega. Let me write the same expression next to you here. So E minus bt ut, its Fourier transform is b plus j omega. So in this, the first term that we have here, let's work on that. You have 2, so that's your b, right? So the answer for this one will be e to the power of minus 2t ut. But you have 1 here, you got 3 here, so multiply it by 3. Now let's look for the second term. The second term here, that's the second term. Okay, you have 3, so your b is equal to 3. So the inverse will be equal to, but don't forget you have -2 here as a constant, -2. It will have e to the power of minus 3t ut. So that will be your x of t. You can, of course, make it look simple or say x of t, and then you take u of t as a common factor. And what's left here? 3e minus 2t minus 2e minus 3t. I hope that was easy to find the inverse.